Next, we are going to implement the model we created for the make versus buy problem to Excel and use solver to solve it. If you recall, in this problem, we have two groups of decision variables. The first group being the number to make for models 1, 2, and 3, and the second group being the number to buy for models 1, 2, and 3. So we have 6 decision variables in total. Next, our objective function is to minimize the total cost, which is the total cost of making and the total cost of buying the 3 types of models. Then the constraints. First group of constraints is the demand constraints. The number we make plus we buy for each model need to meet the demand. I had equal to here, but we also talk about we use greater than equal to make the model less restrictive. And the other group of constraints is taking care of that the resources needed need to be less than equal to resources available. And last one would be the non-negativity constraint. Now, if you are ready, we're going to Excel to create a model for it. So use the same file if you want to put all the problems in one file, but on separate tabs. Okay, so click on here to get a new tab, double click and rename it. Remember, the first step of Excel spreadsheet modeling is to organize the data first. And to organize the data, you can simply just input the table we have here to your model. Okay, so we have model 1, 2, 3. Model 1, model 2. And then I can drag this to copy, and it will copy model 3 automatically here. So, and we have the demand. Okay, so first we're going to just copy everything from this table here. 3,000, 2,900. 2,900. That's the demand. And the hours of wiring, hours of harnessing. Okay, I'm just going to put the heading here first. The 2, 1.5, 3, 1, 2, 1. 2, 1.5, 3, 1, 2, 1. Be very, very careful when you copy those numbers to your spreadsheet. Okay, I don't know how many times I have seen students have a perfect model but does not get the right result, and we check everything. We find they just have a typo here, for example, for a wrong number, and then lead to a wrong result. So be really careful, because when the model gets complex, when there's a lot of data embedded in your model, it's hard to find where the problem is. If you be extra careful when you input the data to your model, you save a lot of time later. Now the cost to make and the cost to buy, 50, 83, 130. Okay. 83, 130. And cost to buy is 61, 97, 145. Okay, and besides those, I believe we have the availability of the resources. So 10,000 hours of wiring and 5,000 of harnessing. We know from the previous example, I'm going to have to put it somewhere here. So wiring available is 10,000, and this is 5,000. Okay. So with this, we have this entire table in our model and also those two. We didn't miss anything here. Okay. Now we're going to start to design our spreadsheet model. So we know that the decision variables are the model of the number of model 1, 2, 3 to make and to buy. So I'm going to just insert 2 rows here. Okay, so here first one will be the number to make, and second one number to buy. Okay, and I'm going to shade all those 6 cells in yellow so that I know these are all my decision variables. Number to make, number to buy. Then we're going to get the objective function into a cell. And we talk about that things are logically related, need to be physically related. So since the objective function is to calculate the total cost, it's related to here. So I'm going to just shift those a little bit, shift them higher. Okay, so I'm going to insert 3 rows and move those to here. And later, when I calculate the total cost, I'm going to use sum product of these 6 cells, the 2 rows, with these 2 rows here. So my total cost equals 2. Okay, so this is my objective function cell. I'm going to make it equal to sum product. See, using the sum product function, we can take the sum product of 2 rows, 2 columns, or 2 arrays. So here I'm going to use 2 arrays. This is my first array, and this is my second array. That's my total cost. Okay, so the sum product of this entire array, 6 cells, with this array, 6 cells. Shaded in blue, remind us this is my objective function cell. Now what's left will be the constraints. Okay, so the first group of constraints, let's just do the resources first because we did this in the previous example. So you should be able to do this pretty fast. Okay, one thing to be very careful is that what we're going to calculate is the resources required in those 2 cells. So let's put it here. So it's like required, and those are available. Since those are the resources required to make the product, so you want to refer to the right cells that represent the number to make. We have 2 rows here. One row represents numbers to make. The other row represents numbers to buy. You want to use the row that's number to make. Please be very careful. Okay, so equals to sum product of the number to make row with the unit resource needed. And we want to copy this cell down to here, so we don't need to type it again. But make sure that when we copy it, we don't shift this row. So we are going to put a $ before the row number, which is the 2 here, okay? So 2, put a $, another $. This way, we will fix this row when we copy this formula, wherever we copy it to, and this row will be shifted. And drag it down. Remember, always click into the cell, the last cell that you copied your formula to make sure you copy the formula as expected. Okay, so here my numbers to make and the unit of resources needed for the harnessing. So I'm going to shade those as my left-hand side of the constraints. Okay, so that's the first group of constraints I did. And for the second one, if we look at our model, it's the demand one is the make plus buy should equals to the demand. So let's think about where should we put it. So it's kind of like those ones need to be equal to the sum of them. Okay, so maybe we just we can either move it to here, but you know, the cost and the buy, this entire part is related to. So instead of moving this row to here to make it like the sum closer, I'm going to just insert another row here and say available. Okay, so the number available, this is so this upper cell is my left hand side. Okay, it represents this part. So my available equals to number to make plus number to buy for this model. So you see this one column represents my model 1. So my model 1's total number available equals to the number we're going to make and the number we're going to buy. And I'm going to just copy it. You see, when you copy it to the right, the column gets shifted. So click into the last cell, okay? And you will see this plus this one. It get copied correctly. Now shade those three as my left-hand side. And we got our model defined. So I'm going to just make some oh, and here when we inserted that new row, the color shading gets copied too. I'm going to just change it to no fill because only this cell is my objective function cell. Now we're going to give borders to those, and I want my objective function cell to get a thicker outside border. Okay, and available. Put all borders and here borders, and maybe make all of them to be centered. And for the cost, remember we said for those ones, let's format them using currency. Oh, I don't want any decimal points, so here change this to currency too. Okay, so if you get this, you are ready to put the information in solver. Okay, so again, first define your decision variables. I want to just make sure it's correct. So I'm going to open this. When you use the analytics solver, before you click the decision, you first select those cells you want them to be the decision variables and then click decision. And you see, now open it, it will be added as the decisions. Okay, so now it's added twice. I'm going to just delete it. Then I'm going to add the objective function. So click in this one and say this is objective. I want it to be minimized. So make sure you choose the minimization. Change it from the default setting, which is maximization. Click OK. And then I have two groups of constraints. The first group, available. So those are my left-hand side. Okay. I'm going to go to the constraint. So these ones need to be greater than equal to, or if you put equal to, that's fine too for this problem. We just want to make it less restrictive, so I always do greater than equal to, because for this problem, when the model is solved, when the total cost is minimized, we are not going to produce more than needed. So the greater than equal to is the same as equal to when the model is solved, when you get the result. Okay, so add another one. The second group of constraint, the resources required need to be less than equal to resources available. And for my version, I have to add here. So these ones are greater than or equal to 0. Remember we said we don't put any numerical values in this solver window unless we are defining the non-negativity constraints. Click OK. Now, just quickly check it. So the decision variables C2 through E3, correct? Okay, my two variable constraints and the non-negativity. My objective function f6, which is this one, to minimize it. Now I'm ready to solve. Click optimize, and then I get my result. See if you get the same result as what I got here. And if it's different, first check if the objective function value is the same. If the objective function value is the same, then it really doesn't matter what value you have here, because later we're going to talk about there could be alternative solutions that give you different numbers to make and buy for the different models, but yielding a same total cost. Because the objective of this problem is to minimize total cost. So if your total cost is the same as mine, the minimal total cost we can get, then the different solution will be just a different way to solve the problem. And if you did not get the same result, then double check your model. First, start from the number you put. So those numerical values you put in this model to see if they are correct. Check those ones first. And then start to check on those formulas you input. For example, the first formula we input, the objective function. Okay, check to see if you use the same sum product of those two rows. Same with mine. And then if this is correct, then go to the constraint. So this should be sum product of the number to make and the unit resource needed row. Okay, make sure you check the second constraint to see if you forgot to fix this row here, then if you have the sum product of the second row versus this row, then it's wrong, because the resources required is resources required to make the product, and we only use this row, the number to make, not the number to buy, to determine how much resources is needed. Okay, so check those 1, 2, 3 formulas. And if those formulas are all correct, then check your solver window. Okay, so to see if you specify the correct decision variables. So those 6 need to be the decision variables. And the objective function, make sure it's a minimization. Okay, so in mine here, I do have it, the F6 minimization. And then the constraints. These ones need to be greater than or equal to these ones. And these ones need to be less than or equal to these ones. So I have the solver window in the old version to show you here. So if you have the same version, older version solver, you can check if you have those correctly. And if it's a newer version, then you would make sure to, you may not have this greater than or equal to 0 constraint, but make sure you check that non-negativity. And make sure your algorithm is changed to standard LP simplex.